we have for the integral test, there are three factors. So for all x that is equal to or greater than 1, the function a of x has to be continuous, positive, and decreasing, right? So if it diverges, that means that it's going to be an infinite number. So basically infinity or negative infinity. And if it converges, then it's going to be a finite number. So that means it's like one possible answer. So like 1, 6, 1/2, like that.
So we're going to be testing out the integral test. And prior to answering the actual integral, you have to figure out if the function is continuous, decreasing, or positive. To find out if it's decreasing, you have to solve the equation for the derivative and find critical values and check if the series decreases, and to check if it's positive for all x values greater or equal to 1. So the first problem is this, and we're just gonna bring it. So a is summation n equals 1 over 3 n plus 4. So the first thing we would want to do is set this up in terms of x in integral form. So we're going to put the integral as 1 to infinity 1 over 3x plus 4 dx. So to find the answer to this, we're going to have to use u substitution. U is equal to 3x plus 4 du is equal to 3 dx du over 3 equals to dx. And then we solve. Equal to 1/3 because of this du over 3. Integral 1 over u du equals, and then we're gonna, this turns into ln, 1/3 ln of u, and then equals 1/3 ln absolute value 3x plus 4 plus c. Or you can write it like this. So now we're going to officially solve for the integral to see if it diverges or converges, and we're going to write, this is the way you usually set it up, the limit as t approaches infinity. T will always be infinity. 1 to t 1 over 3x plus 4, and then we've already solved for our equation, and it's going to look like this: t ln 3x plus 4 over 3 1 to t. So we're gonna plug in t and plug in 1 like we usually do, and it's going to look ln of 3t, and t is infinity, so remember that, over 3 minus ln 3 1 plus 4, which equals over 3. So this essentially equals infinity. So infinity minus, and this is going to be a finite number, so it doesn't really matter what number that is, but because this is infinity, so because there is no finite number to this problem, the series diverges. We're gonna start with example 2, example B. And like mentioned before, there are 3 complete ways to finding if a series converges or diverges. So B is equal to summation n equals 1, 1, and 3. So the first step is set up an integral formation. So we're gonna put the integral of 1 to infinity and replace the n's with x's. So 1 over x to the third dx. And then we're going to integrate. So the answer to that would be negative 1 over 2x squared plus c. Again, the correct formatting defining whether it converges or diverges is the limit as t approaches infinity of negative 1 over 2x squared 1 to t. So we're gonna now plug in our t's for x's, and it's gonna be 1 over 2t squared, and remember t is another symbol for infinity, minus negative 1 over 2 1 squared. So putting infinity on the denominator, this essentially is 0. It's equal to 0. So plus 1/2, and the answer is actually 1/2, and that's a finite number, meaning that this series converges. Doing the last examples, which says use the integral test to find the upper and lower bound on the limit of the series 1 over n to the 3. So we're trying to find upper plus lower bounds of series. So basically, you're gonna set it up like this. Equals 1. So we're gonna be plugging in some numbers, such as we're gonna be plugging in 1 to 6, which is gonna help us find our upper bound. So we're plugging in 1 as n, and that would be equal to 1 plus, if we plug in 2 over here, it's gonna be 1 over 8 plus 3 to the third is 1, so it's 27. And finally plus 1 to the 18th. So when we add all this together, the upper bound is going to equal to 1.22. And to find the lower bound, we're going to be doing something similar. but we're not going to plug in 1 to 6. We're going to be plugging in 1 to 5. So when you add all that together, it's going to be 1 plus 1 over 8 plus 1 over 18. And that's going to equal 1.118, which is our lower bound.
Okay, so we're gonna do the direct comparison test, and for that there are two rules. So if the sum of b sub n from 1 to infinity converges, then that means the sum of a sub n from 1 to infinity also converges. The second rule is if the sum of a sub n from 1 to infinity diverges, then the sum of b sub n from 1 to infinity diverges.
We're doing the direct comparison test. The direct comparison test is very simple. It has two basic rules. So the first rule is if you have a series that is smaller than the convergent benchmark series, which I personally call the mother series, then it must also converge. And if your series is larger than the mother series, then it must diverge. So this goes in ties with the geometric series test, to where if 0 is less than r, which is less than 1, then it must converge, and if it's greater than 1, then it must diverge. So here we have the first example where 1 over n cubed plus 1. So the mother series would be known as 1 over n cubed. The 1 doesn't really matter. So we know that when we plug in different numbers and stuff, that 0 is less than 1 over n cubed plus 1, which is less than the mother series, which is 1 over n cubed. So based on this, because this is less than this, then it must converge due to direct comparison series test due to the rules. So it must converge. So onto the second example, we have 1 over 3 to the n plus 2. Again, the mother series equation would be 1 over 3n. The 2 does not matter. Like, numbers really do not matter as long as it has something to the power. That's what's important. So again, while plugging in numbers, we should get that 0 is less than 1 over 3n plus 2, which is less than 1 over 3n, meaning that the series converges. And the third one, 1 to the square root of n minus 1. The mother series is 1 over square root of n. Now, when we plug in numbers such as, for example, 4, n is equal to 4. 1 to the square root of 4 is equal to 1/2. 1 to the square root of 4 minus 1 is actually equal to 1. This is less than this, meaning this is greater than the mother series. So we would write it like this. 1 over square root of n minus 1 is greater than 1 over square root of n, which is greater than 0. This is for any n that is greater than or equal to 4. due to this, the series must diverge due to the rule that our series is larger than the mother series, the convergent benchmark series, basically. And that's it.